Okay, this is going to be for math, and we are doing Worktext page 253, 254, and then you will need to do reviews, page 251, 252 on your own, also because you don't have homework tonight. I will work with you on the front to make sure you're getting it, but on the back it's review, so you'll do the back on your own. But let's begin by looking at this chart, okay? So we're going to move on, talking about shapes. We're going to learn the words similar, congruent, and symmetrical, or symmetry. All right, so similar means they are the same shape, but different sizes. So notice, these two are both triangles. If you're not looking at the chart, you're not paying attention. Can you scoot over just a wee bit so that he can actually see? Not that he's trying to see, but I need him to try to see, and he can't see through you. All right, this one. So what shape is this?
Triangle.
Notice, both are triangles, but are they the same size?
No.
So similar means same shape, different size. These are both
Rectangles.
and they are same shape, different size. And these are both,
Circles.
okay, but they specifically are actually balls. They're both balls. I don't know that that one's a basketball, but it is a ball. And balls are the same shape, a sphere, but these are both different size. So same shape, different size is
Similar.
Congruent means same size and shape. So even though these are different color, you can see that they are the same size and the same shape. These are exactly the same. Same size, same shape. And again, these are different colors, but they are still the same size, same shape. So that is congruent. Then we come to the word symmetrical. All right? So symmetrical means when it's folded, both parts match, or they are exactly the same. So when you cut it down the middle, this triangle looks exactly like that triangle. Some of you are not looking at my chart. Okay? When you cut this oval down the middle, this half of the oval looks exactly like
The other
half
half.
of the oval. Of this butterfly, please look at the paper, the chart. Stop looking at your paper and look at the chart. Notice the way they divided it in half. What if we divide it in half this way? Would it be symmetrical if I cut it across this way? No, because the top half of this butterfly does not look like the bottom half of this butterfly. But this side of the butterfly does look like this side. So if you divide it this way, it is symmetrical. If you divide it that way, it is not symmetrical. So that's what you need to watch out for when we get to the part where we're going to divide things in half. You need to make sure you're dividing in half the correct way so that both halves look the same. That is symmetry. When you are making something have symmetry, both halves are divided so they look the same. Okay, it makes it symmetrical. Okay, so what is similar? Same shape, different size. What is congruent? Same size and shape. What's symmetrical? When folded, both parts match. Or when cut in half or divided in half is another way to say that. All right, so let's look at the top of your paper. In the orange box, first of all, they show you similar. What shape is that?
Hexagon.
That is a hexagon, and they are same size, same shape, different size. Please stop doing that. Yes, ma'am? Thank you. Look at your paper. We're doing your paper now. We're talking about the orange section, and you are playing. All right, then you look in the middle, and you see, again, hexagons, and they are congruent because they are the same shape and the same size. Then, again, they give us a hexagon, and they have divided that. I am still hearing people playing with their rulers. Would you please put your rulers down and stop making noise with them? So that hexagon has been made symmetrical because they divided it in half and both parts match. Does everybody see that?
Yep.
All right, now we're going to label these in the first section as either similar or congruent. You can spell it correctly because it's right there to copy. Okay, so make sure you're spelling it correctly. Look at the first two. What do you see? What shape?
Circle.
They are the same shape, same size, so they are
Congruent.
congruent. So copy that word, congruent. And number 1. Congruent. Do not write so big that you can't make it fit. Make your writing smaller so it fits, please. Go to number 2, which is across from it. This time you see what shape? Octagon. If you count them, guys, that's 8. So that's octagon. Are they the same shape?
Yes.
Are they the same shape?
Yes.
Are they the same size?
No.
So that means they are
Similar.
Okay, the next one is a,
Triangle.
are they the same shape?
Yes.
Are they the same size?
No.
So that means they are similar. All right, then moving on to number 4. Number 4, what shape is that?
Square.
Square, or you could call it a
Quadrilateral.
quadrilateral. Square is more precise because it does have equal sides. Are they the same shape?
Yes.
Are they the same size?
Yes.
So that one is
Congruent.
congruent. Very good. All right, in the next section, we're going to be doing symmetry, lines of symmetry. So you look at the first shape. If you count all the sides, how many sides does it have?
Six.
It has 8. So what is that? That would be an octagon. A very weirdly shaped octagon. All right. Do you see the dotted line?
Yes.
All right. So where that dotted line is, that's where they're saying that it's folded. If it's folded there, is it going to have a line of symmetry?
No.
No. On either side of that line, that dotted line, they are not the same. So that one does not have a line of symmetry. What we're going to do is we're going to circle the ones that do. All right? The next one, what would that be?
Dome.
A dome or,
Semicircle.
yeah, half a circle, okay? It looks like half of a circle. Where they divided that one, is that a line of symmetry?
Yes.
Yes. One side looks exactly like the other side. They're like opposites. Okay? One side looks exactly like the other side. What?
What type of shape would this be called?
I agree with you. Dome or semicircle, half circle.
But like, it wouldn't be like a polygon.
No, it definitely is not a polygon because that's one curve.
Yeah.
Not all line segments. There is one line segment, but then it has a curved line. But that one you need to circle because that is a line of symmetry. All right, moving on to the next one. What shape is that? That is a pentagon. Look where the folded line is. Are they the same on either side of the folded line?
No.
Could you have made the dotted line be in the right place?
Yes.
If you'd have gone straight up and down, then it would be a line of symmetry. But the way they did it, that is not a line of symmetry. Go to the last one. All right, and that is a oval. Where they divided it, is it a line of symmetry?
Yes.
Yes. The only way that that wouldn't be a line of symmetry is if they didn't put it in the middle. Because you could even go this way in the middle and it would still be a line of symmetry. But if you don't put it in the middle, then it's not a line of symmetry. Okay? Moving on to the next one, we're going to actually take different objects. Now on this one, they have drawn several different lines. Which line is the line of symmetry? And please don't do it yet because I want you to use your ruler when you trace over. You're supposed to trace over, but I want you to use a ruler to make it nice and straight. I want you to use your ruler to make it nice and straight. All right, so which one is it?
The vertical line.
Yes, that vertical line going straight up and down, right through the handle. Any other line you trace, is that the vertical line going straight up and down right through the handle? Does this side look like that side if you do that one? If you do this one, does this top part look up like the bottom part? If you do this one like you were trying to do, does this side look like that side? were you trying to do this one? Why were you doing it like that? It doesn't look the same that way. No, you didn't, because you weren't changing. When I was trying to get you to stop, you still wanted to do that one. No, I said use your ruler. Put your ruler beside the line and hold your ruler still so you can trace it carefully. You understand? All right, the next one is a octagon. Stop signs are octagons. And you need to figure out which one of those lines of symmetry would make it be exactly the same. So which one is it this time?
The horizontal.
Yeah, that horizontal one going right across the middle. That horizontal one. All right, the next thing you see is a baseball bat. Could be a softball bat or bat. So do you know which one's going to make it be symmetrical?
The one that's down.
The one going long ways right through the bat. You don't want to cut the bat in half because the handle of the bat is not the same as the part you hit the ball with. So you want to go right down the middle of the bat, straight down. That's why you need to use your ruler and go all the way through. I think the dotted line even comes out the top and the bottom of the bat, doesn't it? Yeah, so you should go all the way through, straight down, through the bat. All right, that last shape is a quadrilateral. And you need to pay attention on this one because this one's a little tricky because it is a different kind of quadrilateral because it has angled sides, right? So which one of those would actually make it look the same?
The vertical one.
Yes, the vertical one. Only the vertical one. If you try to do the crisscross ones, then you have one fat triangle and one skinny triangle. All right, so if you notice that, look at that. If you try to do one of the crissy-cross ones, you end up with a fat triangle and a skinny triangle, don't you?
Yeah.
But if you do the one that's vertical, then the left is the same as the right. All right, so how many of you agree that this is easy as long as you're paying attention? All right, it's not just about dividing objects in half. You have to divide them in half the right way. All right, one more time. You're going to do some more objects. This time they don't give you options. You have to take your ruler and divide them in half carefully so that you have lines of symmetry. Now, what's the first object? Pear. So are you going to divide it horizontal or vertical?
Vertical.
Yeah, and I would go from the stem. Now that stem sort of makes it not quite be symmetrical. But ignoring the stem, the rest of the pear would basically be symmetrical, right? But because that stem curves, that makes it a little off, doesn't it? But still, you want to go vertical right down the middle of that pear. So the stem is where you want to start, and then try to go straight down. All right, what do you see next?
Violin.
A violin. So are you going to divide it vertical or horizontal? Yeah, you want to do this one horizontal. So that the two sides of the violin look exactly the same. You don't want to have a handle on one half and the body on the other half. That's not symmetrical, is it? You need to have half a handle and half the body for each side that you divide it in half. All right, then we have a birdhouse. Vertical, very good. Go vertical again, straight up and down. From the tip, the crest of the roof, straight down. Right through the hole, all the way to the bottom. Now, do not do that last one yet. Because I'm going to tell you something. What is that last shape?
A rectangle.
It is a rectangle. Now, you could go horizontal, don't do it. You could go vertical, don't do it. Do you know why I say that?
Sideways.
Why do I say don't go horizontal or vertical? What would you have to do to make sure you're at the right spot?
Measure?
Yeah, you have to measure it to make sure you were perfectly accurate. Which way can you do it where you don't even have to bother to measure? Yes, if you go diagonal from corner to corner, you don't have to measure to see if you're dividing in the right spot. If you do, yeah, from corner to corner, and then you have two triangles. You have a triangle on the top. Since it doesn't have angled sides, since it has all right angles, you can go from corner to corner and you'll have two triangles exactly the same. So you're either gonna go from the top corner to the bottom corner, or go the other side, the left-hand side, and go to the bottom of the right. So just go diagonal one direction. It doesn't matter which direction, but if you go horizontal, you'd actually have to measure it to make sure you're in the exact right spot in the middle. If you go vertical, either horizontal or vertical, you have to measure it to make sure you're in the exact right spot. I've had people that did it horizontal or vertical, and then when they did it, this is what they ended up with. Is that really symmetrical? No, it's not really symmetrical because they didn't do it at the right spot. So that's why I don't want you doing that. I want you going from corner to corner. So anytime you have a square or a rectangle, and I'm telling you to put it symmetrical, I do want you to go from corner to corner. That way you're not even having to worry about measuring to make sure you're in the right spot. Okay, turn the paper over, and we're back to similar and congruent. Remember, similar is same shape, different size. Congruent is same size and shape. Can you understand what I'm saying to do? Corner to corner, so line it up. All right, hold your pencil still, and hold your ruler still, you can do it. There we go. Whoops. All right, what do you see on the back of your paper? The first thing you see is? Don't tell me the answer, tell me what shape you see.
Quadrilateral?
Yes, those would be quadrilaterals. Those are actually parallelograms. Are they the same size?
Yes.
Are they the same shape?
Yes.
So that one is congruent. All right, the next one you see is a, what shape?
Oval.
No, we're going to, look at the numbering of it. Number 2 is a cross. We're going across. Another quadrilateral. Are they the same shape?
Yes.
Are they the same size?
No.
So those are similar. Then number 3 is a oval. Are they the same shape?
Yes.
Are they the same size?
No.
So those are also similar. And the directions have the word similar, so you can just copy it. Make sure you're spelling it right. Similar. Similar. All right, number 4 is triangles. Are they the same shape?
Yes.
Are they the same size?
No.
So they are similar. You guys understand that similar means almost the same, but not quite, right? So that's why it's similar. The reason it's not exactly the same is because it's not the same size. All right, the next one, number 5, is a quadrilateral, or you could call this one a rectangle. And are they the same shape?
Yes.
Are they the same size?
Yes.
So that one is congruent. All right, and last of all, we're seeing circles. Are they the same shape?
Yes.
Same size?
No.
So they are similar. Similar. All right, now we're moving on to circling the shapes or the figures that have lines of symmetry. So the first one is a triangle, where they have drawn that line of symmetry. Is that correct?
Yes.
Yes, so go and circle that one. And stop doing that. You're not focused on what we're doing when you're trying to do that ahead of time. All right, the next one is another triangle. Does that one have a line of symmetry?
No.
No, that would not be. Notice the above that dotted line does not look the same as below that dotted line, does it? Could they have made it have a line of symmetry?
Yes.
Yes, if they'd done it the same way they did the other one. The next one is the letter W. Did they make that one have a line of symmetry?
Yes.
Both sides look exactly the same. So circle that one. And the last one is a
Triangle.
no. Count the pentagon. Does that one have a line of symmetry?
Yes.
Yes. That is the line of symmetry. So circle that one. All right, then they give us the letter G.
No.
No line of symmetry. Is there any way to give that one a line of symmetry?
No.
No. There's no way to give that one a line of symmetry. Next we have a circle.
Circle.
Is that a line of symmetry?
Yes.
And then they give us a book.
Yes.
Very good. So you should have circled 5 of those that time. All right, only thing you're gonna do next is to do those division columns. And those are all the 7s, so you'd be writing the 7s. All right, how many of you want me to do the front with you on the second paper? You do. Okay, let's go and do second paper then. Oh, stop.
I'm not losing mine.
It's all right, because some people are. You know what? If you don't want to do it with me, then don't, but I'm going to do it with you. So, first thing you're going to do is look, what do you see? Those of you that want me to do it with you, what do you see? Squares. Are they the same shape? Yes. Are they the same size? No. So they are similar. All right, then we see
Circles.
circles. Are they the same shape?
Yes.
Same size?
Yes.
So they are congruent. Very good. Then we see
Hexagon.
hexagons. Very good. Are they the same shape?
Yes.
Are they the same size?
No.
No. So they are,
Similar.
see, they are not the same size. See, you're getting ahead of me and you're not answering them right. These are not the same size. So if they're not the same size, they are, what are they? Yeah, similar. You need to erase that because you erase it good. Last of all, you see
Octagon.
octagons. Are they the same shape?
Yes.
Same size?
Yes.
So those are congruent.
Congruent.
All right, for the lines of symmetry, the first one you see is a pentagon. Is that the line of symmetry?
Yes.
Very good. Straight down the middle, dividing in half, looking the same. The next one is a,
Triangle.
is that the line of symmetry?
No.
No. It could have been, but they did not do it right, did they? So don't circle that one. And the next one is a pentagon. Is that the line of symmetry? No. They could have made a line of symmetry if they'd done it differently, but they did not do it the right way for a line of symmetry. And the last one is a,
Circle.
is that the line of symmetry?
Yes.
Yes, very good. All right, on the last section, you will pick the line of symmetry, or actually, it's not the last section. One of you have to pick the right line of symmetry and trace it, and the other one you have to make a line of symmetry. Remember, on the rectangle, it is a rectangle, right?
Yes.
Go from corner to corner. Go from corner to corner.